Welcome to Master Mathematics in Minutes. Today's topic is about rational numbers, and we'll cover a couple examples on rational numbers, and we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what are rational numbers? Firstly, recall that integers are negative and positive whole numbers, or counting numbers, with the inclusion of 0. For example, the numbers -3, -2, -1, 0, 1, 2, 3 are examples of integers. Rational numbers, denoted by the letter Q, are numbers that can be expressed as a fraction of the form a over b, such that a and b are elements of the integer set, and b is not equals to 0. Essentially, you have an integer divided by an integer. There are two types of rational numbers. The first one is the terminating decimal, with 0.17, and that can be rewritten as 17 over 100. And 17 and 100 are both integers, and so that is a rational number. Secondly, we have the recurring decimals. We have 0.11111 recurring, and that can be rewritten as 0.1 with the dot on the number 1 to represent the recurring nature of that digit. And that is equals to 1 over 9. So 1 and 9 are both integers, and so this is a rational number. In the first example, we're asked to list any three rational numbers. So we have 2 over 3, 5 over 7, and 10 over 9. So essentially, we have integers divided by integers, and that is the definition of a rational number, provided that the denominator is not equals to 0. In the second example, we're asked to determine if 1.2 is a rational number. So we will rewrite 1.2 in fractional form. If that can be done with two integers, one as the numerator and one as the denominator, then that number is a rational number. So, yes, 1.2 is a rational number, and we'll explore why this is the case, with 1.2 as equals to 1 plus 0.2. So we'll copy 1 over, and we can rewrite 0.2 as 2 over 10. And that simplifies to 1 plus 1 over 5. And 1 can be rewritten as 5 over 5. And we'll copy 1 over 5 across. And simplifying that, we have 6 over 5. So we have an integer divided by an integer, and 5 is not equals to 0. And so 1.2 is a rational number. In the third example, we're asked to determine if 5.3 recurring is a rational number. So with yes, 5.3 recurring is a rational number. 5.3 recurring can be rewritten as 5 plus 0.3 recurring. We'll copy the 5 across, and we can rewrite 0.3 recurring as 1 over 3. So 5 can be rewritten as 15 over 3, and we'll copy the 1 over 3 across. Simplifying that, we have 16 over 3. So essentially, we have an integer divided by an integer, and 3 is not equals to 0. And so 5.3 recurring is a rational number. In the fourth example, we're asked to determine if the square root of 2 is a rational number. No, square root of 2 is not a rational number. Or in other words, square root of 2 is an irrational number. So, square root of 2 is equals to 1.41422135624. And so this decimal is not a terminating decimal, and it is not a recurring decimal as well. And so square root of 2 is not a rational number. To summarize, firstly, recall that integers are negative and positive whole numbers, or counting numbers, with the inclusion of 0. For example, the number -3, -2, -1, 0, 1, 2, 3 are examples of integers. Rational numbers are denoted by the letter Q, and these are numbers that can be expressed as a fraction of the form a over b, such that a and b are integers, and b is not equals to 0. Essentially, it's an integer divided by an integer. There are two types of rational numbers. The first one is a terminating decimal. For example, 0.17 can be written as 17 over 100, and 17 and 100 are both integers, and so this is a rational number. And secondly, we have a recurring decimal, with 0.1111 recurring. And we can write that as 0.1, and the dot represents the recurring nature of the digit 1. So that can be rewritten as 1 over 9, and both 1 and 9 are integers, and so this is a rational number. Thank you very much for watching. This is Master Mathematics in Minutes.